Okay, so I've had at least two people check in, so I'm going to assume that you can both see and hear me okay. We've got, what, 4 or 5 concurrent views. Um, okay, so there's two parts to what I'm going to cover this afternoon. The first one is in relation to the assignment. Now, you know that's due in by 5 o'clock next week. So I've decided to just drag some bits out of the spec and make sure that you cover the relevant bits in relation to what you need to write up for that assignment. It's a bit weird. It's a game development assignment, but there's a lot of theoretical righty-uppy type stuff that's associated with it. So we could do with getting it out the way quick, because assignments 2 and 3 are about what they're supposed to be about, which is about building computer games. We are going to look at another computer game in a bit, because I want to look at building a really simple form of breakout. But I wanted to cover this first, because obviously I talked last week about you formulating a bit of a structure to your documentation using the heading levels in Word, and I think you can add another level to this if you take into consideration what I'm going to be doing sort of next. So I'm not going to go to the assignment brief. You can read that, but what I am going to do is make sure that you have the ability to sort of just take into account what's written in that and the sort of stuff that you should be talking about for each of the sort of requirements and where they map to the criteria. So as far as sort of like the sociological aspects of gaming, there are sort of a lot of what they call for sort of like sociological or games in society bit. There are a lot of sort of concerns which they talk about. So you're talking about sort of like the effects of excess playing time, the effects of social isolation, cost, reality separation, the effects on education. Now, you could split education into two parts, because there are educational games that you can talk about, but obviously the effects on education. So that's the first bit, which are basically talking about the concerns of gaming in society. But then you've got the bits in relation to the benefits of gaming in society. So it could be argued about the benefits of the development of core hand-eye coordination. You can then give examples of things like application into brain training and strategy skills from certain games, giving examples. What is the... It's a weird one, this. Is talking about the future impact on the individual of playing computer games. And obviously there's the growth in the development of applications. Now, what they're actually talking about with this last one is probably things like the growth of demand in the games industry, which is probably what they're going to be asking for. So it might be that this last one, which is the impact on mainstream application development, you can lean that towards the growth in the demand of the requirements of programmers in the games industry. But each of these numbered elements that I've just gone through now, you can split it into two subsections, namely concerns and benefits, and then use each of these as probably subheadings that you can discuss in isolation to cover that. Now, a lot of those were covered in the lecture anyway, so you may as well just carry on and formulate your structure around that. Now, the psychological factors are built around, I think it's a distinction. So the last one, which is this one, they were built around the social aspects, which is mainly the P1 criteria off the top of my head. Definitely the psychological aspects are the D1 criteria. So it could be not just talking about sort of negative and negative psychological factors. It's the effects that they actually put into gaming itself. So, for example, what are the psychological influences on an individual with the use of particular types of sound in computer games? The use of high score listings, mainly for the creation of competition. That's then linked into the competitive aspect of gaming. Obviously, you've got the positive aspects in relation to those, but you can talk about the negative aspects in relation to peer pressure. Now, that can link in with things like the cost aspect of the peer pressure in spending more money for upgrades and things like that. Fun tends to speak for itself anyway. There's the fun aspect. Educational value, yeah, talking about the development of games not just for fun but for its educational value. Definitely linking the competitive aspect into leveling. So the fact that you've got two areas which develop into the competitive aspect, which are things like high score listings. You can talk about the ranking systems as well if there's not a high score as such, but they all link into the competitive aspect of gaming, and obviously that develops into the fun aspect. But clearly you've also got things like the negative aspects such as pressure, positive aspects like some educational value. Obviously you could be decided whether competition is positive or a negative aspect, but things like the competition aspect can be deemed can be talked about in a sort of more positive light. And then obviously you've got the positive aspect of the use of sound in this as well. So there's plenty to be going on with that. So that's sort of like the early stages of it. The genre type stuff, a lot of it you've talked about before. So we've covered things like genres when we did games design. So a lot of that you could sort of look at again. The only thing that comes out really poorly is a poor use of examples, and that's what I want you to concentrate on afterwards. But you've at least got things like RPGs, adventure games, real-time strategy, that's a 5, platformers, simulations, sports, stealth, combat, FPS, educational, and MMOs. So that's 13 individual genres which have been identified in these. What I would probably suggest where you can is where you can merge them together, then do so. But what I would probably suggest, if you're going to, for example, merge, let's just think of one, maybe combat games and first-person shooters into a single write-up, which is fine. There's nothing wrong to doing that. But in the text of it, I would probably put... let's rub that out. I would probably think about using the heading to cover both, so that you cover your own back. So what you're saying in sort of in respect of that one, for example, is I would say as a heading, I would say combat games stroke first person shooters, if it's relevant. Although you can have sort of action games as combat games, sort of like your Street Fighters and stuff like that, but it might be that you have to really show an external examiner that you're addressing it with examples in a combined way, rather than an examiner saying, well, he's not really covered combat games by talking about first person shooters. The fact is that you're addressing that it's combined, so that you're sort of covering two things in one go. But just be mindful of that. Other things that you can talk about, the development of gaming platforms, mainly talking about the development of movement from console applications to PC applications. Prior to console applications, you could go into sort of arcade development, leading into consoles to PCs, handheld, and then online. So you've actually got the ability to cover a lot of these, like handhelds, standalone platforms on PCs, online. We'll talk about phones, internet, network gaming as well. So you could sort of give examples of network gaming for those as well. And obviously you've got a PC bit which covers that one. So again, you've got 1, 2, 3, 4, 5 subsections you could talk about there. Then obviously link your gaming platforms into the developments in technology, because obviously what's happened in the development of these technologies as you've gone further and further on have been developed in graphics, audio, which are obviously a lot better. Programming wise, give some examples of how artificial intelligence has developed, and talk about some developments in hardware and software in terms of the improvement in the level of gameplay. And in that respect then, you'll have probably covered those. So basically what you've got are, I would say, 3 areas that could be discussed. You've got your gaming types, your gaming platforms, and then link your gaming platforms into your technologies. So you've got 3 subsections. Okie dokie. That should be okay with that one. So that's sort of like an overall guide as to what we're going to need for those. I'm going to address some other questions now because you've already started saying things. Will the live stream be saved to go over it later? Yes. The URL that you've been sent to link to this should then link to this being played again. Do you know if we've passed all our lessons? We had a table on Teams, but nobody explained what it is. Haven't got a clue. I don't know what you mean by passed all our lessons. Not got a clue what you're on about. You might have to clarify that a bit later on. Passed all our lessons. I'm assuming you're on about passing modules in semester 1. I'm a bit sort of clueless on that one. I'm not 100% sure what that means. What I'm going to do for the second part, okay, because obviously you've got assignment 1 which is ongoing. I'm going to show you another example of a little project in Phaser, which is to build a basic breakout game. And then what we're going to do on that one is I'm going to show you an example of how it works, talk through the code, and obviously then I'm going to release the code on the VLE so you can have a go. What that'll mean in terms of subsequent assignments is that it'll give you some idea of the sorts of projects that you can develop for yourself, because if you think about what we've done a top-down in terms of the Asteroids type game. We did a sort of map navigation platformer type game which we covered last week, and then we're doing the breakout type game this week. That means you've got the ability to develop a different type of game for your own. Assignment 2 is the design aspect, and I'm not covering that until after assignment 1's handed in, and then assignment 3 will be the build. If you want to start the build early, that's entirely down to you. Assignment 2 is more a designy type affair, so I'm more worried about getting you through that first, but let's worry about getting assignment 1 in next week, and then we can cross the bridges with everything else after that. So what we're going to look at this afternoon is a basic breakout game, so just give me a second while I just prep up. By prep up I mean have a cup, drink of tea. So we'll close that down and we'll get rid of that. we might need that, but I'm going to give you a quick demo first. So in order to do that, I'm going to fire up my web server. There we go. And I'm just going to run the project for you. Oops. Okay, so that's what we're going to be looking at this afternoon. It's a basic breakout game. Obviously, graphics-wise, it's not the most fantastic in the world, but it'll cover the vast majority of the things that you want to do. Obviously, you can manipulate this and change your graphics around and develop extensions to it. It locks the player into the edges of the screen. You're all sitting there watching me play games. Can't believe I'm doing this myself. But that's the sort of thing that we're going to be looking at this afternoon, and we'll just see how it goes on. I'm not playing that anymore. I'll be here all night. So, how do we put that together? Well, in the first instance, what we need to do is have a look at the structure of the project. So what we've actually got is it's a bog standard phaser project. I've only got one HTML file. I've got phaser.min, a basic style sheet, and a folder called images. The actual blocks in this game are images, which I've created, and they're dead easy. I've basically created 3 white graphics, a white square for the ball, a vague oblong for the brick, and a large oblong for the paddle. Rather than use shape objects, which would take ages, and it's easy for me to just throw them together in Photoshop or something like that, which is a bit easier in order to throw them together. Just look at some of these in context. So I'm going to open up each one of these in Notepad++ to give you an idea of how they all stitch together. So that's the HTML file. It's not particularly difficult. There's nothing there that you haven't seen in anything else. I've got the game container, which has been specifically structured to store the game area, which is a bit weird because it's not a bigger game area like you've had before, but everything else is the same. There's the reference to hello world.js, which you can call whatever you like anyway, and phaser.min.js, which is obviously the phaser library. The style sheet is all it does is reference the game container block. The only thing I've done is I've resized the width and height to fit in the game, which is in this case is 400 by 450. Everything else is more or less the same, so it just maintains, you know, a nice pretty colour for the background, a different colour for the background of the game, and 400 by 450 for the game container. All the hard work is in the JS file. It's not that difficult. I have restructured it in the same way that I restructured the game last week, where I've got one main state with the entire game in it, but it does give rise that all your functions fit inside that main state, and your game initialization is right at the end. Those of you who had a play about with the platformy type chasey round game, collecting game last week, I did it using this method because you can create multiple states, main state being your first state, which I've identified here. So we have a new phaser game at 400 by 450 running in game container, and I've added the main section, which is this one called main state, to the game, and I start that main state. Because it's all encompassed in this one section, I can create other states after it. So effectively what you're doing is you can create multiple levels in the same game. I think I know Joe last week, he did this with the sort of platformer type stuff. So it's perfectly functional to go and do this. And you can create multiple levels within the same game. It's actually quite a good way of building a game with multiple levels, because the older way that we did it makes it a little bit difficult to achieve. So I'm going to walk through these three sections. They're not that difficult actually, and I've filled the whole thing full of comments to give you an idea of how each of these bits work. So it should be generally easy to get this version working, and then all you can do is just change your graphics around and make it do what you want it to do really. But I'll talk you through each of the sections. Preload, pretty easy. All you do is preload the assets. I've only got 3 assets in this. I've got paddle, brick and ball, all referencing PNG files in the images folder. The images folder I've pulled together because it keeps everything nice and neat, so it doesn't make your game folders look an absolute mess with sort of bits of rubbish flying everywhere. So that's a pretty straightforward one. The create function is a little bit more complex, but again it's not that bad. I've set the background colour to I think it's that blue colour. I can't remember where I got that colour from, but it basically colours the background colour stage of the game. The beauty of it is if you actually create it through main states, you can have different background colours for each state, which basically means level 1 can be blue, level 2 can be red, and so on and so on and so on. I've applied the arcade physics engine so we can have movement and collision, and then I've applied the physics engine to all the game objects. I'm actually using variables to store the status of left and right, so I've added left and right keys and stored them in 2 little variables called this.left and this.right. So I've added phaser.keyboard.left, phaser.keyboard.right, and we store the left and right properties, so we can identify if left is pressed or if right is pressed. And then I've added the paddle to the bottom of the screen, which is at the bottom, the little paddle that moves left and right. And I've had to set the immovable property of the paddle to true, because when the ball collides with the paddle, I don't want the ball to effectively use its physics to push the paddle out of the way or dislodge it. So it's an immovable object in that it withstands all collision. It's so then that the physics will allow it to bounce back off rather than to sort of stick to it or fly right through it. The collide world bounds. Make sure the paddle doesn't fall off the sides of the screen, so you can't scroll left forever or scroll right forever. And then the difficult bit is this one, which basically is creating the rows of bricks at the top of the game as a group. So I've created a group called bricks, and we talked about the use of 4 next loops last week. We have used them a couple of times before. So what I have got is an array which basically stores the bricks in a group. So what we end up with is a bit like a 2-dimensional array, and in that 2-dimensional array which is 5 by 5. That is rubbish. Start that again. So what we've got, 0, 1, 2, 3, 4, and 0, 1, 2, 3, 4, and then effectively it's an array, 5 by 5. You should all be okay with arrays by now. So we're using the array to reflect the structure of the bricks inside the game. So all we're doing is applying a brick to each of those elements in the array. You're not sitting here watching me fill this in, but I'll do the first 2 rows. But the thing about it is, for each one, we're going to set the property of each of those bricks. So we're going to set X and Y properties based on going through the 2 for next loops. So that we can visit each one of these in turn and set the locations for each one, and you'll see the maths for that in a second. So let's revisit this code. What we've now got are our 2 for next loops, which go from 0 and keep going as long as they are less than 5. So it'll go 0, 1, 2, 3, 4, and setting the brick position is all based on this little piece of code here. I'm going to try this in Microsoft Whiteboard. I don't know whether it's going to let me put this in or not. Oh my god, right, well, I've learned something myself. So basically we've got a piece of code. All I need to do is be able to move it now. So we've got that piece of code. What I need to do is be able to trace how that actually works. So let's say we take, let's take that one for a start. Okay, so let's say I is 0 and J is 0. Okay, so that relates to 0, 0 and those positions. So the position is, this bit relates to X, this bit relates to Y, and this obviously is the object that we're adding. So the object that we're adding is a brick. Okay, so how does it work? We're creating a brick object and we're adding the sprite at 55 plus I times 60. So 55 plus I times 60. So this is I. We'll do the same for J in a minute. 55 plus 0 is 55 times 60. Okay, so that is the X calculation, and J is the Y calculation. So what we've there got is 55 plus 0 times by 35. So again, 55 plus nothing is 55 times 35. Someone can do the maths on that if they want to, but that'll give you the value of the X location, Y location. Now the thing is, once you take that into account, that and that will change when we move from that one to that one, because we change from 0 to 1. So in the first instance that will stay the same, but that will increase by 1. So we go round again, we hit that one, and it'll be 56 times 60, which again will give us that one. So the first brick will effectively be there, and then that one will be one further along. And then we hit that one, which will be 2. So it's 57 times 60. And again, it'll do that one. 58, 59. And then once we get to that one, we reset. That'll change back to 0. And this will then change to 1. So it moves it further down. So we basically use the loops to move the bricks along, and we generate everything as we go along. So that then adds everything in a nice pretty set of rows, and we make them immovable so that when the ball hits them, they don't dislodge or move. We just detect the collision, and then once we've set the X and Y, I and J, or X and Y property set by these, we add them then to the group. So by the end of this set of 2 loops, we've created effectively a 2-dimensional array full of bricks that we can basically use in our game. We then add the ball to a start position, which is 200, 300. Give it a 200, 200 velocity. Now, if you wanted to, you could change that to a random number. For example, between, I don't know, 50 and 150, or 100 and 300. You could do it in the gameplay so that the further on you go, the faster the ball gets. And then we set the collide world bounce property to true so that it bounces off the walls, and we also set the bounce property, so that it has the ability to bounce off. So that then sets up the entire function in order to do the set up the bricks, set up the ball, and set up the paddle. So everything's there in that respect. In the update function, we've got the control of the paddle. So remember, we set up 2 variables called left and right, and we've said if left is down, we set the velocity to minus to move left. If the right is set, which is the keyboard right key, we move right, and we move that in a positive velocity. And in the case of if nothing has been pressed, we set the velocity to 0. So there's no continuous movement or gravity or friction or anything like that. It's just straight left, right. And then all we do is we set up the collisions. So we've got a collision set up between the paddle and the ball. And effectively, there is nothing that we do when we add the collisions, because the velocities of both have been set. All that will happen is, because the ball has had a bounce property set to it, when these two collide, the bounce on the ball just means that it bounces right off. We don't need to call any functions, because it's just going to fly off. It's not killing the bat, it's just flying off in another direction. But when the ball hits a brick, we have to have a function to deal with the ball hitting a brick. So we've got the arcade collision between a ball and the bricks group, and we have a function called hit that we've called underneath. We'll go and look at that in a sec, and these always stay at null in this, so we don't need to worry about those. If the ball hits a brick, we send the ball object and the brick object from the group, and then we kill the brick. We've done kill before, it just makes it disappear, and then everything carries on as it normally goes. The only death situation in terms of this game is if the Y property of the ball becomes greater than the Y property of the paddle. What does that mean? Well, if the Y property of the ball and the Y property of the paddle, let's just clear the canvas. Let's just have a look at how that works. If this is the bottom of the game and you've got the paddle, and you've got the ball, let's take that as the ball, the current measurement of y, and there's no anchor dot set to in this case, so it's just top left. The x goes in that direction, the y goes in that direction. The measurement of y goes from here, which is 0, to whatever the value of y is. Doesn't make any difference. The ball measurement in y is a measurement from the top at 0 all the way down to that one there. And again, that will vary because the ball's moving around all the time. So the condition was if, not paddle, it was ball. If ball.y becomes greater than paddle.y. What does that mean? So if that distance, which is ball.y, becomes greater than the distance of paddle.y. So what are we saying? If that distance becomes greater than that distance, well, what does that mean? Well, in this example, paddle.y is greater than ball.y because that value is bigger than that value. If we were to take another example, and again we do a measurement from there, and again we measure from 0 all the way down to there, paddle.y and ball.y, in this case, paddle.y is less than ball.y, or, as we've written it here, the value of ball.y is greater than paddle.y. What does that mean? Well, the player has allowed the ball to go past the value of the paddle, in which case it's going to hit there, in which case you effectively lose. And how's that measured? Well, if the ball.y is greater than paddle.y, we do game.state.start, which basically means that we restart the game. I'll show you that in a second when I relaunch it. And that's actually pretty much it. It more or less covers everything that you need to do to build a very basic game. I'll do the game restart status, which I've not done on the others, just to give you an idea of how that works. So the value of y at any of these points is always going to be greater than the value of paddle.y. But straight away, as soon as the value of y becomes greater than, for the ball, is greater than that of the paddle, it will always reset the game. Alright, so that's your losing state. Right, so that's effectively it for that. So I'm making the PowerPoint for the assignment. I'm going to put the PowerPoint for the assignment that I've just covered at the beginning. I'm going to put that in the assignment folder. I'm also going to put, unless I've already done it, I'm just going to check for you now. I think I've already put the breakout game on the VLE. Let me just check. Yeah, I've already put creating a simple breakout game on there. It's a zip file. You just have to extract it and put it on your web server. And you're free to play with that as and how you see fit. Obviously, your main priority with this has been is to obviously get the assignment 1 boxed off as best you can. I'm just looking now. I've not set up the Turnitin class for assignment 1, but what I will do when I've finished is I will put the assignment 1 PowerPoint guidance in there, so you can have a look at that. This to answer your question, if I've not already done it, you can watch the live stream again to watch my annotations over the PowerPoint slides. And that, I think, is pretty much it. So what I'm going to do is I'm going to leave the chat window open for a spell. If you've got any particular questions you want to ask, you can do. But the main priority, I think, is assignment 1 boxed off. I'm going to put those PowerPoints in there, get them uploaded now, and I'm going to get the I'm going to get any questions answered that you feel need to be answered in that respect. So, unless anybody's got any specific questions, your priority is to get assignment 1 finished, and I'll set up the Turnitin class for 5 o'clock next week. Okay, does anybody have any questions they want to ask in the chat room? And the world goes quiet. So what if you want to ask me any questions, you can either send me a question in Teams or you can send me an email. Now, what happens with the live streaming stuff is that you can use the same link to watch the video again. It takes about 20 minutes, half an hour before the stream. Formulates the text chat, so nobody's really asked any major questions on that, so it's not that much of an issue. But give it about 20 minutes, half an hour. You should be able to watch it as soon as I've ended the stream. But if you really want to watch the text stream or the text chat, that'll appear a little bit later on. So if nobody's got any specific questions, I will now get stuck into uploading this stuff on the VLE in terms of the support for the assignment 1 and the Turnitin class for assignment 1, and I will get that sorted now. Okay? Last chance. Any more problems? Any more questions? What do you mean by access my system files? If it's a case of being able to access, for example, a particular file relating to the breakout game, then obviously all you need to do is just download it and extract it onto your web server. But if I'm not sure what you mean by system files, you'll have to make that a lot clearer. W drive, right. I think I know how to do this. I'll do it from your perspective, but I'm not 100% sure whether this is going to work. So if you go to Wigan and Leigh College website and you go to the students section, there is a bit on here called WLC Cloud. And what it allows you to do is it will allow you to log in using your normal college login, and it will give you access to your W drive, hopefully. I suspect it's very busy because lots of people are accessing it. In fact, I think it's very busy because people are trying to access it. That's the first thing that's gone wrong all day. But effectively, that's how you do it. you access WLC Cloud, and it's like a little web front end for your W drive, and you can access stuff and download stuff and things like that. I'm going to try once more. It might be you have to wait until a bit later on, because it looks like the whole world's trying to access it. Have another go at it. If anything goes wrong with it and it continues to be a problem, then obviously we'll have to react to it. And I think we've still got technicians who are trying to sort of sort things out, but it looks like it's continuously trying to do it. Right. So, does anybody else have any other questions? Alright, if I end the stream now, I mean, we're just coming up to the hour mark, so I'm going to get all this stuff uploaded onto the VLE, and if you now plod on with the assignment 1 stuff, and like I say, if, like Shannon, you've missed like the beginning bit, you can always hit the link, and you can watch this from scratch. Okay. And if that's it, I think we'll finish it there. Okay, so hopefully we'll see you next week. We'll have a bit more of a chat about assignment 2 next week, just to make sure that everybody's more or less up to date with what they have to do for that. If you've got any comments, how well this went, or I've missed something out, or you're a bit stuck on something, by all means you can send me a message or something like that, write it in the text chat, and then we'll just see if I can improve on things next week. Alright, thanks a lot people, stay indoors, wash your hands, you know the score, and I'll talk to you next week.